Assalamualaikum and greeting to RR Dr. Melvin Ganjit Hong and Mr. Abdullah Muhammad Tahir. My name is Nur Adiba Farhanah binti Mat Nubakri and I will be presenting my FYP titled Study of Bamboo, Flake Reinforced Polymer, Composite Material Ignition and Flame Spread Property. I will start my presentation with the introduction. Okay, what is this composite? Bamboo flake reinforced composite material is fabricated based on the combination of UPR, unsaturated polyester resin, and bamboo flake or an epoxy resin with bamboo flake. Okay, why this composite? Because this composite is chosen for its excellent performance in various of industry, particularly those that based on woods. And how the study is conducted is through a flammability test, which are horizontal and vertical burning tests to characterize the material ignition and also flame spread property. Okay. Next is the problem statement. The problem statement of this study, there are because of limited previous study as the past researcher more focused on the mechanical property of this composite rather than the fire property. And the second one is to improve the existing products such as oriented strand board and for future work so that this study will become beneficial for other researchers. And the third one, okay, the objective. The main objective of this study is to characterize the bamboo flake reinforced polymer composite material ignition and flame spread property. And this main objective is specified to three objectives, which are to design an experiment for characterizing the material ignition and flame spread property with ISO 3795 and American Standard Testing D635 as a reference. The second objective is to characterize the flammability property of this composite bamboo flake reinforced polymer composite material. And the third one is to confirm the material feasibility for the selected application based on the material ignition and also flame spread property. Okay, move on. This is the literature review of the study. As you can see on the left side, this is an example of a few articles that serve as a guideline of this study, and the outcome of a literature review that is conducted throughout this FYP process is that the horizontal and vertical UL94 tests according to the American Standard Testing D635 and also D3801. And the example of result that can be obtained from UL94 tests are, for example, flaming draw, as you can see there, combustion time, and also combustion rate. And from literature review also can get the LOI value of UPR and epoxy, as you can see there. For UPR is 21%, as for epoxy is 20.2%. Next, okay. ASTM D635 is the standard test method for determining the rate of burning as well as amount of duration for burning of for polymeric materials. As for ASTM D3801, the right one, present a small-scale laboratory test utilizing a 20mm flame to determine a comparative burning characteristic of plastic materials. Okay, next. Okay, the methodology of the study, as you can see there, the start of this study will start with the specimen preparation of 5 different materials, which include for composite material or UPR reinforced with the bamboo flake and epoxy reinforced with bamboo flake. As for the polymer material, which is here, the pure matrix are polyester resin and epoxy resin. As for the fifth materials are the pure bamboo. After I've completed the specimen preparation, I'll proceed to the instrument preparation and followed by flammability tests, which are horizontal and vertical burning tests. And then once the result is obtained, such as ignition and flame spread is obtained, then I will proceed to the next step. And if the results such as ignition and flame spread result are not obtained or the data are not synchronized among the materials, then the flammability tests are redo. However, if the result is synchronized, the next step is for the result validation and verification, followed by documentation and discussion. As you can see on the left side, this is the specimen preparation step. This is the 5 materials that is prepared with a dimension of 120mm long, 13mm wide, and 4mm thickness. Okay, next, this is the flammable test. Flammable test is designed and performed based on the American Standard Testing Method, D635, ISO 3795, and also UL94 standard. Okay, and the picture here shows the FLIR 1 thermal imaging camera. For the A is the setup during flammability testing. As for B is the infrared imaging, and for C is the digital camera image. And the involved device include drying vacuum oven, FLIR 1, digital level box, and more. Okay, this is the vertical burning test, which is one of the flammability tests that is conducted on the specimen and is performed on vertically oriented test specimen with the distance of Bunsen burner here, with the specimen was set to at 19 millimeter, and the flame was put to the specimen for 10 seconds before withdrawn, and the result that is obtained from vertical burning tests are the self-extinguishing time, the amount of the specimen that is burned, and the dripping of the burning test specimen. As for the horizontal burning test, is different as the specimen are held at 45-degree angle to the burner flame, and the distance between the burner, Bunsen burner, and the specimen are also 25 millimeter away, and the flame that is applied on the specimen are only 5 seconds. And the data that is collected through horizontal burning tests are, for example, burning rate, weight loss, and flame dripping. Okay, next, result validation and verification. As you can see here, for both vertical and horizontal burning tests for composite material UPR with bamboo flake, for the validation, COV is calculated for both flame time and burning rate. As for the verification, result verification is done through a comparison between the 5 different materials. Okay, next is the result and discussion. Okay, here shows the temperature profile during a vertical burning test of all 5 materials, which include epoxy, UPR, pure bamboo, bamboo flake with epoxy, or with UPR. Okay, as you can see, the temperature of both composite material falls over time, and both composite have a lower temperature change over time. And as for epoxy resin, when it is exposed to heat, because epoxy is made of BPA and epichlorohydrin, when it is exposed to heat, epichlorohydrin will polymerize aggressively and quickly, result to a faster flame time of epoxy resin. As for UPR, it will release a substantial number of pyrolysis product when it's burned. Okay. Next, this is the flame behavior for composite material, which is bamboo flake with epoxy or bamboo flake with UPR for vertical burning test. And as you can see, that shown in the table is the early flame time of both composite material and the temperature after 1 and 2 minutes of burning. Both composite shows a decline on the temperature over time, and neither of them show a melt pouring behavior when burned. Next, okay. This is the flame behavior of polymer material, which is epoxy and UPR. Okay, the flame spread for epoxy resin travels slower than UPR. And however, both show a melt dripping behavior. As for UPR, the reason for its melt dripping behavior is because of polyester. Okay, the polyester in the UPR is heat sensitive. That's when it experiences heat, it will melt, shrink, and deforms. Okay, melt dripping behavior is harmful in a fire as it will lead to a secondary igniting. Okay, next, this is the pure bamboo flame behavior in vertical and horizontal burning tests. As you can see, in both tests, it shows that flame time of pure bamboo are the lowest among the materials, and it also revealed that pure bamboo has the shortest and the smallest flame spread. Okay, next, this is the flame behavior of polymer materials during horizontal burning tests. Okay, as you can see, they both experience melt dripping behavior, and this is after 1 or 2 minutes of burning, and 2.8 minutes, and also 4.7 minutes after burning. Okay, as you can see here, this is the flame behavior of composite material, which is bamboo with epoxy and bamboo with UPR, which show that the flame spread of both composite material increase as time increase. Okay, next. Okay, for the flame time, this is the graph flame time from vertical burning test of 5 different materials, and you can see there, bamboo flake UPR have the highest flame, have the longest flame time. As for pure bamboo has the lowest. Pure bamboo has the lowest flame time because it has high organic silica concentration. Therefore, it have a short time. However, the condition of inside the bamboo itself that is porous that contribute to the burning. Okay, epoxy resin is made of chemical that are not combustible or flammable and can endure temperature up to 177 degrees Celsius, and its combustion time is lesser than UPR. Okay, the ability of UPR to continue burning is due to the reason because of after the flame is removed, styrene monomer contained inside the UPR itself is a flammable organic hydrocarbon are burned because in the presence of oxygen, all hydrocarbon are burned. Okay, the flame period is significantly greater when the resin are strengthened with the bamboo flake. As you can see from the table. Okay, move on to the burning rate. Okay, as you can see there, pure bamboo have the highest burning rate. As for the UPR has the lowest one. Okay, the high aromatic content of epoxy resin lessen the tendency of the material to ignite. As for the burning rate of UPR are faster because it is a flammable resin, and the difference in the carbon content between the epoxy and UPR itself is the one that result to the burning rate, because the that explain the burning rate of each one of them, because the burning rate increases as the carbon chain length shorten. Therefore, pure bamboo that has the longest carbon chain length of any 5 materials have the longest burning rate, and moisture content also influence the both flame time and also burning rate of all specimens. Okay, move on to the conclusion. Okay, the first objective. The first objective is achieved by designing a vertical and horizontal burning test and also specimen preparation according to the standards. And the second objective is met by performing a vertical and horizontal burning test on the composite material in accordance with the specification. And the flammability properties are illustrated in a graph, table, and figure. As for the third objective, it is achieved as the burning rate of composite material, both of them, A and B, as you can see there, is lesser than the burning rate for laminate flooring and OSB board. Okay, next, the recommendation for this study is the first one is for a large scale testing. Second one is for a chemical treatment for moisture removal lignin, and the third one is for an adding flame retardant. This is this is the example of reference that is used in this study. This is a few of them. Okay, that's all from me. Thank you.